Okay, this problem says it takes 500 joules of work to compress a spring 10 centimeters. What is the force constant of the spring? Um, so, um, and what you're going to do is you're going to compress it 10 centimeters. Okay, it takes 500 joules of work to compress a spring. Okay, when you're compressing it, the spring force is in this direction. The spring exerts a force in that direction, so you are having to exert a force in the opposite direction. Okay, the spring force is given by minus kx, so we'll call it the applied force. The applied force is kx. Okay, all right, so the work done by the applied force is F dx. Okay, and what are you doing? You're going from this initial position to that final position. Okay. So the work done by you is kx dx from 0 to x final. You compressed it from 0 to the final x position. Okay? I mean, we can, well, we'll keep this x initial just so that you have a general expression for it. Okay? So this would be kx squared by 2 x initial to x final, k by 2 x final square minus x initial square. Okay, that's the work done by the applied force. So in your case, x initial was 0, x final was minus 10 centimeters, minus 0.1 meters. Okay, so 500 joules was equal to k by 2 minus 0.1 meters squared. Okay, so k is equal to 1000 joules divided by minus 0.1 meters squared. Okay, and this works out to 10 to the power 5 Newton per meter. Okay, so the spring constant is 10 to the power 5 Newton per meter, 100,000 Newton per meter. What does that number mean? So your weight is about 1,000 newtons. 100,000 newtons meaning 100 of you would have to stand on the spring to compress it 1 meter.
And here are the 1 meter. So it's a pretty strong spring.
There are about springs in your car that are about 25,000 Newton per meter. So probably a spring in a semi truck or something like that. Okay. Somebody Google that. Spring constant in semi trucks.